Good morning, everyone. My name is Japan, and today we are going to explain about the RLC circuit. So here you can see here is some notations about series RLC circuit. So V represents the voltage of the power source, which is measured in volts. Second is I is the current in the circuit. It is measured in amperes. Third will be R is the resistance of the resistor. It is measured in ohms. And fourth is the L, inductance of the inductor. It is measured in henries. And C is the capacitance of the capacitor. It is measured in farads. And the last one will be Q. It is the charge over across the capacitor, and it is measured in coulombs. Here we are coming with the governing equation for RLC circuit is given by L times di over dt plus Ri plus Q over C equals to ET. So now I will explain what they represent. For the first, times di over dt is the inductor voltage, and Ri is the resistance. Thus, Q over C is the capacitor voltage. And the last one is they will come with the sum of voltage in function of t. So here is the initial conditions. The current flow, there will be no current flow, and thus there will be no charge produced. And finally, it comes out with the I equals to dq over dt, and it means current equals to rate of change of charge. So our aim in this subsection is to determine the current IT of the charge, QT, or both. Then two methods are available for us to solve RLC circuit problem. First, we will solve in Q terms, and the second we will solve in I terms. So for discussions, let us consider some follow problem. The series RLC circuit has a voltage source given by ET equals to 100V, a resistor R equals to 20 ohm, and inductor L equals to 10 Henry, and a capacitor C equals to 6260 power of -1. If the initial current and the initial charge on a capacitor are both zero, so determine the current IT and the charge QT in a circuit for t larger than 0. And now we'll come with method 1.
Okay, so I'm Yuping. I will explain the method one, which we solve the problem in Q terms. Um, First, like what we say above, the governing equation is L di over dt plus Ri plus Q over C equal to E in term of t, where the given L is 10 and the given R is 20, E in term of t is 100, and C is 6260 power of -1. And the initial conditions, like what we say just now, I in terms of t zero, when t equal to 0, I equal to 0, and then when t equal to 0, q equal to 0 too. Therefore, when we subs all the given value to the governing equation, we'll get 10 di over dt plus 20I plus 6260 q equal to 100. Okay, so in the first step, since I equal to dq over dt, when we sub inside into the equation, we'll get double derivative of q with respect to t, times 10 plus 20 dq over dt, and plus 6260 q, which remain constant and equal to 100. So when we divide both sides with 10, we'll get a simpler form, which is double derivative of q with respect to t plus 2 dq over dt plus 626 q equal to 10. So since the equation 2 is a non-homogeneous equation that can be solved, so we can use method of undetermined coefficients which will be explained in step 2.
For step 2, we have to solve the non-homogeneous equations first. And then the first thing first, we need to find the QH and the QP. For the value of QH, we have to find the CE, which is from the equation 2 above the equation. We will come out for m squared plus 2m plus 626 equals to 0. Then we have to find the roots of these equations, which is -1 plus and minus 25i. Therefore, our QH is E exponent negative t a cos 25t plus b sin 25t. Then for QP, we can get the value ft equal to 10 from the equations, and then we find the QP equal to C naught. And the C naught is nothing similar terms in the QH. Find the value of our C naught. Our C naught, we will find it from the equation 2 above and count the equation 0 plus 2 multiplies 0 plus 626 multiplied by C naught equal to 10. Then our value of C naught is 10 per 626. Therefore, we combine QP and QH into QT. We will come out the equations E exponent negative t a cos 25t plus b sine 25t plus 10 per 626. Then we will continue our step 3 to solve the question.
So in step 3, we have to determine the A and B constant in the equation which we find in step 2. So from the initial condition, Q equal to 0 and T equal to 0, 0 will equal to A plus 10 over 626, and A will equal to negative 10 over 626, which we can find out after we substitute the initial condition in the equation above, find out in step 2. So after that, we substitute the constant A in the equation, then we have to find the following B. But we don't have the equation of I in the function of t to apply the condition. So we have to differentiate first the q, and we find that I equal to dq dt equal to exponential power of negative t times 250 over 626 minus b times 6 sine 25t plus 10 over 626 plus 25b cos 25t. After we apply I equal to 0 when t equal to 0, we found out that b, constant b will equal to negative 1 over 1565. Therefore, the equation q will equal to e power of negative t times negative 10 over 626 cos 25t minus 1 over 1565 sin 25t and plus the constant 10 over 626. After we get the formula, we differentiate it and we find the formula I will equal to exponential power of negative t times 250 over 626 plus 1 over 1565 sin 25t plus 10 over 626 plus 25 times negative 1 over 1565 cos 25t. After you simplify, we finally get that I will equal to 2 over 5 exponential times exponential power of negative t sines 25t. So follow with method.
Okay. Now we are going to solve the problem in items, which is method 2. So we have Gaussian equation and we have the constant given. So we start the constant given into the equation. We will get 10 didt plus 20i plus 6260 q equal to 100. So now we want to solve in item, so we have to eliminate the q. So we know I is equal to dq dt. So we just differentiate the equation in respect to t. So we will have 10 d, d, d2i dt square plus 20 di dt plus 6,260 dq dt equal to 0. Okay, so after simplify, we will get d2i by dt square plus 2 di dt plus 626 I equal to 0. So we notice that this equation is a homogeneous equation, so we can solve it by the method of determining coefficient. Okay. So we will have a characteristic equation which is m squared plus 2m plus 626 equal to 0. We will find that the root m is equal to -1 plus minus 25i. So we write it in the IT form, which is a exponential power of negative t times a cos 25t plus b sine 25t. So step 3.
Right, so I'm now to explain about the following step. So after we have the equation of 3, which is from the IT, from the previous step. So now if we obtain the initial condition, which is I equal to 0 when t equal to 0, hence to get the I equal to 0, the A must be equal to 0 since cos 0 will be 1 and it will be impossible to getting 0. So hence A equal to 0 and we will get the following equation IT equal to B e power of negative t sine 25t. So hence how to find the B? So using the condition of Q equal to 0 when t equal to 0 as same as I equal to 0 when t equal to 0. So even though we didn't have the QT of equation, so we're using the equation for equation 1, which is di over dt plus 2I plus 626q equal to 10. So hence now, if we substitute I equal to 0 and t equal to 0, di over dt will in the condition of t equal to 0, and plus 2I in the condition of 0, which is 0, and plus 626q in the condition of 0, which is also is 0, is equal to 10. So hence now, we could conduct that di over dt in the condition of t equal to 0 is equal to 10. So now, if we have I prime over t, I prime t is equal to the di over dt. So hence, if di over dt in the condition of t equal to 0, I prime in 0 is equal to 10. So now going for the following step or step 4, by using the IT equation of B of the above, so you have to differentiate it to get it B equal B I prime t equal to B negative e power of negative t sine 25t plus e negative power of negative t 25 cos 25t. So by applying I prime 0 equal to 10, so we got that 10 equal to 25b and b equal to 2 over 5. So hence, if substitute b equal to 2 over 5 in the previous equation, we will find out that the IT equation will be 2 over 5 e power of negative t sine 25t. So the a will be ignored as the a is equal to 0. So now we are going to the step 5, which is the last step of the method 2.
Okay, so step 5 is to determine the equation for the charge QT. Since I equals to dq over dt, so integrate it equals to 2 over 5 exponent negative t sine 25t. Right to t to get qt. But this process is very much relying on the complexity of it. To get the equation, we have to relate to first method. So anyway, qt is equals to integrate 2 over 5 exponent negative t sine 25t dt. By using integration by parts or tabulated method, we obtain qt equals to exponent negative t in a bracket negative 10 over 626 cos 25t minus 1 over 1565 sine 25t plus c. Apply the initial condition of q0 equals to 0 to get c. So 0 equals to negative 10 over 626 plus c. Therefore, c is equals to 10 over 626. Lastly, the charge qt will be qt equals to exponent negative t in a bracket negative 10 over 626 cos 25t minus sine 25t over 1565 plus 10 over 626. As the conclusion, we found out that both methods can solve this example, and both method has its pros and cons. Anyway, method 2 is way longer in my opinion because it has repeated step 3 and step 4 from method 1 to get the step 5 in method 2. That's it from us. Thank you.